I'm here with Brad Deshane, who is representing David Clark Company, and as you can see from the props he's brought with him, David Clark is a Worcester company that is well known for the space suits that they design and the helmets, and they're even branching out into more, and that's the subject of your talk. Welcome.
Hi, thank you. Yes, that is correct. So, founded in 1935, and then World War II kind of brought us into the G suits, and then this, 1969 the space, and that just got us into spacesuits, and then we did communications for the helmets, and that got us into just microphones and earphones, and now we develop headsets for the aviation market and for any high noise application, really, stadiums, and our intercom systems for marine applications as well, and fire departments all across the country. Today, we're going to talk about a lot of things, actually. David Clark Company is where I work, right in Worcester, Mass. We do tons of things, which I'll tell you about. A lot of it is audio related, and that's why this is called What Are You Hearing? Or whatever I called it. What are you listening to? That works. So I'm Brad. I went to school to be a computer engineer. In college, I guess, not school, but and the reason I did that is because when I was about 12, I built a computer, bought all the parts, was really interested in how things work, took apart all my video game consoles, stuff like that, put them back together, and math came really easy to me in high school, so I just kind of put those two things together and decided, you know what, I'll try computer engineering. So I graduated in bachelor's in it and applied to David Clark Company shortly thereafter, about 5 years ago now, and they liked me and hired me. And my official title is an electronics design engineer. Now, where's the computer name in that? I barely use my computer engineering skills that I learned in college, but the great thing about electrical and computer engineering is they're kind of both the same thing in the beginning in college. And then you get the tools and you learn a little bit about a lot of things that you can just branch out into anything you want. So I didn't even know I was interested in this stuff until I started working there. So it was kind of cool to learn about something I had no knowledge of, and now I do it as a living, so that's kind of cool. David Clark Company started in 1935. We made, can anybody tell what we started making? No, brassieres, bras. That's what we started making, actually, and girdles. And we ended up using that material during World War II to make the G-force suits for the pilots because they were becoming unconscious during World War II flying their planes. So we used girdles and we made some air bladders to keep their blood pressure together and to keep it in the right spots. So the first G-force suit was made out of the same material the girdles and bras were made of. So that's a little fun fact. Then, obviously, the 60s was the first mission to space and all that good stuff. So we went from our G-force suits to making spacesuits for NASA. I think, yep, there's their logo there. And so a lot of our, we still do that today, actually. All the space flights, all the mission flights, usually the suits are made by us and David Clark. We always put our logo on them, too, because, got to make awareness of yourselves for anybody else who might be flying out in space. But yeah, from there we started developing the helmets, and now we make all the helmets that go with our suits too, which is kind of awesome. So the whole suit is built right in Worcester, Mass, 20 minutes from you for NASA. That's pretty darn cool. Then we started working on the communications equipment for inside the helmets, the microphone and the earphones, so they could talk to everybody and each other without having to take their helmet off. And then from there, we started making headsets for pilots just to protect their hearing while they're flying, the military. Then it's branched out to even like stadiums. When you go to a football game or a concert or something, they need to protect their hearing, but they also need to talk to everyone to see what's going on. So that's where a lot of our stuff is done now. And then we have a small branch that obviously does the NASA stuff still, because we send people into space every so often, but people are always flying and stuff. So we do that stuff a little bit more often. So this is actually our latest and greatest headset here. It's called the DC-1X. I didn't come up with a name. But I did help with it, and it's a pretty cool device. What this does is powers off some batteries, and you can obviously talk to somebody. This is for a pilot, usually, in an aircraft. Oh, whose phone was that? Just kidding, I don't care. Yeah, so a pilot would wear this when they're flying and when they're on way, waiting to take off and stuff like that. And what it does is it protects their hearing from all the jet noise that's constantly going while they're flying, because you got to protect their hearing because they do it every day. And this one runs off batteries, because what it actually does is not only do you get less volume because you're wearing something over your ear, but there's some electronics in here that take the sound around and they basically get rid of it. So that jet noise goes away or is a lot less significant. And I'm actually going to demonstrate that with you guys in a minute. I have a sound clip that I'll play, and I'll have you guys try on the headset, and we'll power it on and off, and you can see the difference. Noah?
Will you have to try on the suits?
Yes. At the very end, we will try on some spacesuits. Yep. I had to bring these in because they're just so cool. I don't work with the spacesuits specifically, but I mean, I love space, and so do most kids, so I figured I'd bring them in and let you try them on. And it's obviously the history of our company, which is important.
When did they make those? When did you make those originally?
The spacesuits? Well, these two are from 1970s, but obviously we started a little bit earlier than that. The mission flight's probably in the 60s or so.
So when they went to the moon with those suits, have been the ones that your company produced?
Yeah, I believe so. I'm not 100% certain, but I mean, it matches with our timeline. And we have tons of suits up there. And I mean, we're doing it now, so I would imagine we were doing it back then as well. We've been with NASA for quite some time, so I would assume that's a safe bet. At least certainly, maybe not the one that they go out on the moon with, but the one they would probably wear inside the capsules and stuff we would probably be a part of. Because obviously these aren't equipped to go out on the moon with, but they're the ones, the orange ones that everyone always takes their pictures in. That's what these are, so like Buzz Aldrin and Neil Armstrong and everybody.
Do you work with the native labs at all?
I'm not sure, to be honest. We have an oceanology department, and we have a few departments up on the 4th floor that do a lot of the government work and the space and stuff that I'm not a part of, so I don't really talk to them too often. This also has Bluetooth, so that the pilots can listen to their music. But they don't allow you to listen to your music while you're flying, because that's not safe. So they can only listen to their music when they're just sitting in the plane waiting for people to board and all that stuff. Because back then we found out that people, actually I had a gentleman in the first class who said that he would put little earbuds in his ears, and he wore one of these over them to listen to his cassette tapes back in the 70s and 80s before Bluetooth and all these other technologies existed, because our headsets have been around forever. So I wanted to demonstrate this, and then we'll talk a little about what's happening as well. So would you want to try? So you can hear it, you can put that on. It'll obviously get quieter because you have that over your ear. But now, if I power this on, whoa, went right away, huh? Pretty cool. Not bad. So we'll pass that along and we'll demonstrate this, and then we'll talk about a little bit about what's going on. You hear the difference? Kind of cool? Pretty cool, huh? Yeah. You hear the difference?
Yeah.
Pretty cool, huh? Yeah. Feel like a pilot wearing that thing? Feel like a pilot?
Yeah, I feel like.
Now what about an ambient, like someone's talking?
Yep, that's where these plugs come in. So they all plug into a panel, and then they have a hardwired connection to the other person who else is wearing a headset. So they're always in direct communication, and that sound that they're hearing mixes with the audio.
I have a problem.
You got it.
But if someone was talking that wasn't connected with the microphone system,
You'll still.
noise cancellation would eliminate it?
It wouldn't eliminate it. So you can kind of play with the frequency range that you're eliminating. So where we cater towards engines for jets, we get rid of the low frequency rumble that damages your hearing. So, human speech is kind of in like the 4K, 5 kilohertz range. So it would be muted for sure, but you could still hear it. We don't, because you have to be safe, because this is a pilot. So if there's an emergency and one of the flight attendants comes in, they have to hear. So we have to try to make sure that, this is life and death sometimes in emergency situations. So we can't be that good of sound suppression. Where'd it go?
I can really hear you. Oh, I hear it.
I turned it off.
Oh,
I'm power cycling so you can see the difference. Yeah, it went away. That's why we have these plugs. So when you talk into the panel, it actually generates what they call side tones. So your speech comes back into your own ear, so you're not yelling to try to compensate for what you're not hearing yourself, because by nature we hear ourselves.
So are those headphones similar to when you go into a shooting range and stuff like that?
They make different variants, right? So I'll actually explain that in a minute. Any parents want to try it out at all? Back to your question, actually. So for the gun range, they call it like hear through is the technology. So they'll listen at the ambient noise, but when they hear something loud, they'll mute the volume and then bring it back up. So other than the bullet, you'll actually hear normally. It'll just send the audio through because there is microphones in these, and then so it'll detect that noise and clamp that volume momentarily and then bring it back. So it'll be like you're not wearing anything at all. Pretty good. And like I said, you can hook up your Bluetooth and stuff like that. So let's talk a little bit about what is going on in that to do that. The class before, they know about frequency and stuff like that. Do you guys know about frequency a little bit? A little bit? Well, exactly. So it's just, sine waves, stuff like that. So let's just talk about the human hearing for a second. Humans hear from 20 hertz, very low frequencies, to 20 kilohertz on average. And as you get older, that goes away. So these are very high frequencies. And then there's frequencies beyond this that are inaudible, like your cell phone, your Wi-Fi. Those are all 2.4 gigahertz and stuff like that. Those are all completely inaudible, and they're used for data and information and all that stuff. But humans, when they're young at least, as you get older, you kind of lose some of this stuff. But on average, you'll hear 20 to 20 kilohertz. And what we're doing essentially is if we take a sine wave here, just say that's a frequency, that's jet noise. It's a little more complex than that, but just to simplify things. This is a frequency that the microphones on the outside of the headset are picking up. And what they'll do is they'll listen to that. And if this is our time domain here, and this is positive and negative frequency here and here, then obviously if you have a positive number here, if you put a negative number here and add them together, you get 0. So what our headset does is it takes this exact frequency here and we just shift it in phase, they call it, 180 degrees. So this point here is now here, this point here is now here. So what we'll do is we'll do this and then this. So now we'll just take the frequency and we'll do that. So when you add everything together, you get 0, and that cancels out the frequency. There's electronics in each dome board here. There's PC boards here. And there's obviously the main one inside here that does a lot of the work too. Obviously it does a lot of the keypad stuff and the Bluetooth stuff as well. But I also wanted to talk about the analog and digital side of things, because this takes in microphones, which is an analog signal, and then we do things with them in the computer side. How many of you are actually interested in the science fields and want to be engineers and stuff like that? Well, if any of you are ever interested in computer and electrical engineering, it's definitely an easier time now to be one than it was back then. Because back then, when you were designing circuits and stuff like that, you had a bunch of things that you had to figure out values for, and it was a pain, and it took forever. And nowadays, you have computer chips. So you can interact with these with a computer, and you can do tons of things with whatever you have coming in and going out of these now. And it's a lot less complicated, because once you know how to do this once, you can do it, for all these different applications. And you don't need to figure out new values necessarily, because you can just control them on the fly with your keyboard and your mouse. It's really easy once you get the hang of it, and it's really fun too. So that was analog on this side here, and that's kind of a digital side of things. So other examples of analog and digital, these are vinyl records. Do you guys know vinyl records at all? All right, that's cool. They're actually making kind of a comeback right now. But this is an example of analog audio, because it would just be a needle scraping on some bumps in these grooves here, and it'd go right out to a speaker, and you'd get your music coming through. Others examples of analog are cassette tapes, which kind of died. And then we have digital formats such as compact discs and obviously MP3s that you have on your MP3 players and iPhones and all that stuff now too. So why did we go from analog to digital? And like, you know, are there benefits? Are there bad things about it? So if we talk on the analog side of things, you can have infinite resolution, infinite time, infinite detail. You can do whatever you want in the analog world. Computer is just binary, square waves, ones and zeros. So how do you get from this to over here is what they call sampling. So what we do is we take little bits of information of the signal at, you know, we can't get everything because that's analog, it's real time, it's real world. So you get little bits of information and you can translate them into digital signals by just, there's some complications, but it's kind of complicated. But just know that you basically take the analog audio and you can sample it because you can't get everything, and you end up with some binary that gets read in, and stuff like that too. But you have to be careful because if I do this, what I just did here, and we sample that, what's that look like? That's not what that was, right? You need to sample it a lot faster and more often to get anything close to what you had before. And that's something you have to be careful about because as we go to the digital world, you lose something that the analog had. That's kind of why vinyls are making a comeback. The audio sounds better on analog vinyl records than it does in CDs and stuff because we're losing something when we go from analog to digital. Digital is easier, obviously, because what I showed you with the computer chips, but it's also nice because it's less susceptible to things from the outside, interference. If you're near power lines with analog stuff, you can pick that up. In digital, it's hard to pick that up because you're just so 1 0 1 0 1 0. It's repetition. It's very definite. Yes, Noah.
Is all like the big circular discs? Are those only like are those non-singing music like without someone talking, or are they able to work that in somehow?
The vinyl records here?
Yeah.
Yeah, it's everything. So it takes in the microphone inputs. It takes in everything. It's just they put a microphone in and everyone's talking. So yeah, it's not just instrumental. It's the singing as well. It all gets summed. It all gets mixed together, and it gets output onto the when it's making the record with the lacquer, and you know it etches little things in with the lacquer. So I wanted to explain a little bit about the difference between analog and digital and where we are now, and that this headset does some of that because obviously speakers at the end of the day are analog. It's what you're hearing, so that's analog, as is the microphone. But to do anything we did with the fancy stuff with shifting frequencies and stuff like that, we have to get it in the digital domain, and that's where the whole analog to digital conversion has to come into effect. And then obviously you have to go back to it when you're going to be putting it out on speakers and stuff like that. Did anybody have any questions about any of this stuff? Obviously it's kind of complicated. Yes?
Thing, like you said with the football players, you do the same thing with the NASCAR drivers and stuff. Like
Exactly, yeah. We'll put electronics in their cockpits and stuff. We have systems in the Indy cars. For Indy 500 and stuff like that, where we'll have systems that the race car driver can listen to and talk to their pit crew, and then they have the spotters out in the stadium looking at see when they can turn, stuff like that. Absolutely.
Now, is it almost close to that one where it zones it out because of their car being so loud, being in it because my brother races cars.
Yeah, you might. It's going to be a lot different from like where it looks like sense because they can't be wearing this. Yeah. So, but I mean, certainly some of the technology is probably there. It might be enough that these ear seals are enough to keep a lot of that out too, that they might not need the extra. But I'm not actually sure about that. I'm not really sure, so that's a good question. A lot of what I do is not only design the products, but I design the test equipment for products too. So obviously whenever we make something, we have to make sure it works before we sell it. And that's a very important thing about engineering is that you have to make products, but you have to know how to fix them when you make them, and you need to know how to make sure that they are working so that they don't go out broken to somebody. So I do a lot of the test equipment stuff as well, which is really fun because I get to deal with like actuators, a lot of mechanical engineering and stuff like that. And that's the fun thing about engineering, and like I said before, with different fields and stuff like that. Because if you wanted to get into a concentration of engineering where like you were designing those chips, for instance, well, there's chemistry involved because you're using boron and other elements to figure out and to make those chips and to make them behave as they do. So it's really interesting engineering and how all these STEM topics are really linked together. Obviously, math is in engineering and stuff, but you can use. They're all really melded together, and there's a lot of different fields you can go in. But it should take a while to get you guys in and out of suits. So why don't we try on some spacesuits, huh? Those are easy to take apart. So it's actually really fun. I actually just learned about this yesterday because I don't really deal with the spacesuits, but I wanted them for you guys. So that's the helmet right there. You can try that on, take a picture or something if you want. Look at you, you're ready to go. Just gotta be careful. Huh?
How do I get it up?
How do you get it up? Well, it's up as it's gonna be on you, I think.
I like it like the zipper up.
Oh, well, you gotta get down there and reach for it, that's all. There's one. Let me turn here. I'll get the other one going. All right, that's zipped up. We can even button you up if you want.
Can I do the helmet too?
Oh, absolutely. I'm not gonna go halfway.
Let's zip it. No,
So this is fun. I like this one a bit better because this ring goes on secondary and it's sometimes a pain to put that on. So this has got to go over your head like that. And we will zip that up with this guy. I bet you guys didn't think you were trying on spacesuits today. I don't know how many times you'll get a chance in your life to do this. But it's pretty, I love that the fact that David Clark has the history it has, just how far we've come from spacesuits to what we do now and what we're going to do next. I have no idea, and I just want to really be a part of it, and I hope some of what I talked about today interests some of you. Maybe I'll see your application someday. That'd be cool. Because, I mean, it's only 20 minutes away from you guys here, so it's not too far.
Noah, you're about to go in space.
You ready?
Oh, in the hood.
I don't know. You might want to do this yourself so don't break your nose. So, I'll do that. Gotta link these up like that. Close that. We'll lock you in so I can't get you out, maybe. I can't lock you in.
You breathe.
And then you can do that.
Yo. Oh my god.
Can you breathe?
Yeah. There's a hole in here. Hello.
We actually, I don't know if you guys probably didn't watch, but the parents did. There was the Red Bull Stratus project in 2010, I think, or 12 actually. The guy free fell from the edge of space. That suit was made by David Clark Company. And obviously, we would say that we made it because he survived and it all worked out well. If he didn't...
If he didn't, you say, I didn't make it.
Exactly. That's what you do. I don't know where the zipper is on that, so we'll just button you up a bit here.
Oh, this metal thing's really cold.
It's cold.
You're part of the United States, like, you're the national.
This person must have been pretty short.
Why?
Whoever ordered this.
Yeah. Why aren't these locked? There we go. There you go. You're in.
All right, time to go. Let's go. Oh my god.
Cool, huh?
This is cool.
Yeah. Doing the moonwalk?
Yeah.
So you'll have to kind of get your shoulders out first, I think, here. Because that's not going to come over your head. So you're going to want to, or maybe it will because you're...
Wait. This is.
Yeah, you want to get your sleeves out first and try to... Yep. Yep, there you go.
Okay. Who else wants to try the helmet?
I think everyone tried that wanted to try here. Yep, you got it. Nailed it. Okay, that works. It's like you're getting ready to go outside in the winter. You gonna go shovel? No.
Well, it would have to be really warm. It's freezing up in space.
Those don't seem as heavy as what snowsuits would be.
No, probably. They probably won't protect too much.
Rogue.
Yeah, that one's really low. You want to try everything on, or you want that on?
I'll try everything.
Everything. All right, going for broke here. In the back, so you want to lift up the front end, so we have some of the suit actually. Lift the front up so we can put your hair back there. Unless you want your hair zippered in.
No.
All right. It would. I'm hoping not to catch any snags here. You're the first female of the day to wear this suit, so good on you. There's quite a few females in this room. I'm excited. The first group was all guys, so, but I'm excited to see that there's, you know, potential for women in the science, more women in the science and engineering fields. Because we need you guys. You guys bring a lot to the table with your creativity. And I hope that the STEM fair can turn into the STEAM fair, because arts are very important. They enhance the science and technologies because it gives you a creative mind. I think we're past the hair. Nothing hurting yet?
No.
Good. That's a good bet there.
Here are political speak.
Are these the same? We'll find out, I guess. I'll let you put the helmet on. Cool. Heavy, yeah. Try carrying them in. That was not fun this morning. You are in. You're going to space camp. These are your air tubes here. So these would normally be fed down below, and they'd go up into your helmet. And this is like your pressure release valve here, because obviously you have to pressurize the suit so it feels like you're on Earth inside your suit, right? And a bunch of pockets for things. You know, your CD player here, and no, probably not. But some of them one of them has a pocket for a knife, I think, because if you're parachuting and you need to cut the line. Yeah, this one has the knife pocket here. Yeah, you want to try the orange one on? Okay, so if you saw her do it, I guess you can either get on the floor or just step in if you want. And you get one leg there. Yeah, you're figuring it out. You want to put everything on?
Yes, please.
You got it. What good manners. How you doing, Noah? You getting it?
Yeah.
Let me know if I hurt you with your hair. Some of it's sticking out here. Your hair. You wanna turn this way? Thank you.
The camera.
There. Bring you there. And lock you in. You're in. Let's get you out of this. Hopefully your hair is